Hi, in this video I'm going to present you a tool which is used for power quality analysis. So we have here script, PQA and R version 2.3. Let's see the capability of the script. So by executing the script we have here four options. Option 0 is the script automatically creates the scenario needed for power quality assessment based on an input file. You can see it here, the input file. I'm going to show you immediately. Option 1 is power quality assessment and report, in which the harmonic distortions and impedance for each order are going to be analyzed and report in a report Excel. Option number 2 is numerical optimization of harmonic filters, in which a genetic algorithm is employed to optimally determine the filters, harmonic filters parameters, reactive power, tuning order, and quality factor, so that um, all the emissions for any orders to be below their limits. And option number 3, in which the plots for harmonic distortions and impedance are going to be exported in a folder. Okay, so we are going to work on this industrial example from DIgSILENT. Please note that this is just a demonstration of how the script works. So first of all, let's run the first, actually option 0, to create the scenarios for power quality analysis. For this, as I told you, we need an input file. We have here the input file. In power quality report folder, we have the input file. I'm going to open it. Okay. And this input file has two sheets, scenarios and limits. In scenarios, the user must introduce in this table the names of the elements that he wants to alter. Let's say alter their attributes. In the second row, we have the class of each element, as you can see. And in the third row, we have the attributes of each element, of each object. Yeah? And with yellow, the user in first column must introduce the names of the scenarios, and from column 2 onwards is going to introduce the value of the attributes of each object. So for instance, here in object gen1 is a class of elm seal. The attribute is out of service, and in case 0, first scenario, case 0 is going to be out service is going to be 0. In case 1, out service is going to take a value 1. So it's going to be out of service, this generator. For instance, for this filter, column F, in case 3, the attribute out of service is going to take value 1. Yeah? So it's going to be out of service. Yeah? So in this way, the user can introduce whatever object that he wants and with any value of the attribute that he wants in each scenario. Let's look at in limits. In limits, the user must introduce the bus's name in first row, the bus names and their corresponding harmonic limits. Yeah? For 2 to 50. Okay, so this is the input file. Now let's create the scenarios. But first I'm going to present you the inputs of the script. So here we have the path where the input file and the report file are going to be created. Yeah. here we have tolerances, and here we have RLC sensitivity. Actually, these two options, if are enabled, they are used to increase with a certain percentage the line length, transformer reactances and resistance, the resistance for the harmonic filters, and the inductor of the harmonic filters, and the condenser of the harmonic filter. Okay, here in external object we have the we have main transformer 1 and main transformer 2. This is are used in tolerances assessment when the tolerances are enabled. And we have harmonic filter 1 and harmonic filter 2 object introduced here by the user. So let's first execute the script and create the scenarios. Choose option 0. Here we have information. Here we have a warning. So if we would have some scenarios here, they will be deleted. Okay. And as you can see, these scenarios are created. Also in the output window, we have what happened in each scenario. So according to the input file, we can see that for Gen 1 attribute observe is going to be 0, as you can see here. For Gen 2, the same, so on and so forth. Yeah. Let's see, for example, the values for K3. Sorry, let's see for K3A. But first of all, let's activate K3 for 3A. Activate. Okay, and we are going to follow the input file. So we have Gen 1 is in service 0. As you can see, is in service. Gen 2 is in service also, is this one here, is in service. Gen 2 has a active power of 10. Let's see. Is 10. DC motor 2 is out of service. It is this one. You can see it is out of service. Harmonic filter 1 and harmonic filter 2 are in service, are 0. So as you can see, they are here, are in service, both of them. And for CM1, it's a line, it's out of service. So this is the line which is out of service. Okay, so now that the scenario has been created, we are going to proceed to the next step.